So now we're going to talk about universal modus ponens. So remember, we previously discussed modus ponens, but now it's going to be universal because it's going to involve the universal quantifiers. So the format for universal modus ponens is the following. For all x, if px then qx, here say P of A for a particular A, therefore Q of A. And remember, before modus ponens was valid, universal modus ponens is also valid. All right, so let's look at an example. Let's say I want to rewrite the argument using quantifiers, variables, and predicate symbols. And I want you to decide after that, is the argument valid or invalid, and justify. So here's going to be my argument. If an integer is even, then its square is even. K is a particular integer that is even. Therefore, k squared is even. So we're going to notice what our predicates are here. What are the properties that we're talking about? Well, we're talking about an object being even and its square is even. So those are going to be my two predicates. So we're going to use e of x to mean that x is even. We're going to use s of x to mean its square, x squared, is even. So now let's translate this. The objects I'm talking about are integers. So my universal part, it'll be for all x and z. And then what did it say? It was an if-then statement. If it's even, then its square is even. So if e of x, then s of x. And then the second predicate, k, is a particular integer that is even. So this would be e of k. K is even. Therefore, s of k. So we've rewritten the argument using quantifiers, variables, and predicate symbols. So now we can identify, if we look, this matches up with universal modus tollens. So that's going to tell us that this argument is valid. This argument has the form of universal modus ponens. So I can conclude it is valid. All right, let's look at one more example here. Let's write the conclusion that can be inferred using universal modus ponens. So it's going to say if T is any right triangle with hypotenuse, C, and legs A and B, then C squared equals A squared plus B squared. This is the Pythagorean theorem. That's our first premise. The triangle shown is a right triangle. So I'm about to draw the triangle with both legs equal to 1 and hypotenuse C. Therefore, blank, and the triangle I'm going to show. Here's my right triangle. I didn't draw this the greatest because these two sides should be the same length. 1, 1, and C here. So, if we're using universal modus ponens, right, you identify your two predicates, right? Here's my X is a right triangle with hypotenuse C and legs A and B. Then we have this conclusions in our first premise. Here we have a particular triangle. And so all we've got to do is apply that formula that I underlined in red up here, apply that to this particular triangle. So you would get that C squared equals 1 squared plus 1 squared. And that would be the conclusion you would need to fill in.